Hi guys, so plate tectonics, one of the most interesting topics in geology. You can see here on this map, the plates are marked on here. So when we were mapping earthquakes and volcanoes and mountains and ocean floor features, we were finding the boundaries of the tectonic plates because more activity happens at those boundaries. Like for example, right here, you can see this is the Ring of Fire. And at the Ring of Fire, there's a lot more earthquakes and volcanoes because the plates are crashing into each other there. So that's so there's a lot of activity there, and we know that that's why there's a plate boundary there. You can see here in this map that the arrows show whether they're crashing into each other, sliding past each other, or pulling apart from each other, and different things happen at those different boundaries. So let me talk to you really quick about the different boundaries. You can see in these two pictures, these are convergent boundaries, meaning the two plates are crashing into each other. When they crash into each other, if one plate is more dense than the other, like for example oceanic plates are more dense than continental plates, then the oceanic plate, since it's more dense, will slide underneath the continental one. It'll melt down there, and that melted magma will rise and form volcanoes or mountains on the continental plate. So that's what we see at those type of convergent boundaries. And then like this picture down here, if it's two continental plates crashing into each other, a lot of the times it will form mountains. And the cool thing about that is what happened with India. So let me show you India on here. Right here, the Indian plate used to be further down here. Over time, it moved upwards, and it actually crashed into the Eurasian plate right there, where you can see those two arrows there. And that's where the Himalayan mountains are, because when these two continental plates crashed into each other, the extra crust needed somewhere to go, so it crumpled up and made the Himalayan mountain range, and that's where Mount Everest is. So that's what we see. When two continental plates crash into each other, we see a mountain range. Now, divergent plate boundary is when two plates are pulling away from each other. Magma from the mantle comes up through that crack, and it actually creates new crust there. So when plates are pulling away from each other, the youngest, newest crust is going to be right there, and the oldest crust is going to be farther away. That happens at the mid-ocean ridge. The mid-Atlantic ridge is right here. It comes in between Africa and Europe and the Americas on this side, the mid-Atlantic ridge right there. And you can see, according to the arrows, that those plates are moving away from each other. As they move away from each other, magma comes up to the surface and creates new ocean floor crust there. So these continents, like North America and Europe, used to be next to each other, but the Atlantic Ocean is widening because these plates are separating and new crust is coming up in the middle there. And then the last type of plate boundary you need to know about is a transform boundary. That happens when two plates are sliding past each other. When they're sliding past each other, they get caught a little bit, and then tension builds up, and then when that tension is released and they slip, it causes earthquakes. That happens a lot in California. You can see right here, these arrows are showing that these two plates are sliding past each other by California, and that causes a lot of earthquakes in California. So that's what a transform boundary does. And then you also need to know about fossil distributions. So when we did that fossil puzzle, we colored all the same fossils the same color, and then you cut out the continents and put them next to each other. You could see that the same fossil could be found on two different continents because those continents used to be next to each other, and then because the tectonic plates shifted over millions of years, now they're far away from each other, but the reason they have the same fossils is because they used to be next to each other when those animals or plants lived. So you need to understand that as well. That's more evidence for plate tectonics. So I hope that was helpful. Please ask me if you have more questions, and good luck on the quiz.